What if we, without agenda or requirement, and through associative conditioning, operant training, gave animals words? What would they do with them? And how could we begin to explore how they use those words in terms of analyzing their expressiveness? Are their expressions random? Do they have body language that can corroborate and hint at intention and preference? Do their expressions give us an idea around their values? What do they find meaningful? And lastly, could their expressions also be a vehicle to other aspects of enrichment outside of the AAC devices? Could they have enrichment that is brought only because of the icons in the words that they select? These are the questions that we analyze through a new framework we've developed because of a little Goffin's cockatoo who had 5,000 words, she said, over the course of 7 months. And we developed this framework to try to analyze, what do you do with all these words? And how can we explore expressiveness? How can we explore themes of meaning and value? And how can we see how her words are a vehicle to other kinds of enrichment for her life? I'm so proud and honored to be sharing today on behalf of my team. Ellie talks about the weather, evaluating the expressive and enrichment potential of a tablet-based AAC system for Goffin's cockatoo. My name is Jennifer Cunha, and I'm going to share my screen and get us started. This project is a collaboration between researchers from Northeastern, MIT, IUPUI, and Parrot Kindergarten. AAC devices have been in use for centuries, and they can be low-tech, such as paper cards or paper symbols or sign language, and they can be very high-tech, like speech boards on the tablet. When it comes to animals, animals have been taught token exchange systems. Lana pioneered speech board systems, and also some primates have learned sign language. AAC use in non-human animals is difficult to fit into a framework that's been designed for people. The frameworks that exist already generally look at language skills or motor skills. There are not a lot of consistencies between frameworks. So when we looked at different frameworks that already exist for people, none of them really fit what we're looking for, which is evaluating the expressive potential and the enrichment potential of AAC devices for animals. This is our subject, Ellie. She's a Goffin's cockatoo. She presented at a young age with severe behavior problems like biting, screaming, aggression toward other animals, property destruction. And when she was young, I began teaching her word associations. That was in 2012. In 2019, we migrated them onto a commercially available speech board app on a Samsung Galaxy Tab A. Her learning style that we do with her is associative conditioning. So she learns to press something and get the outcome repeatedly, a second vocabulary word and outcome, and then we quiz her on them. And then we also look quite a lot at her behavior correspondences. Ellie has been involved in research in the past regarding speech board and other things. Her speech board, for example, looks like this. This is the main menu, and the main menu drops into submenus. The submenus may drop into deeper submenus. She has over 200 words on her speech board that were analyzed for this project. This is an example of associative training for her. I'll show you only the first part of it for purposes of time, but she learned two word associations and have quizzes.
Touch apple?
Apple.
Very good. Apple. Yeah. And touch apple?
Apple.
Good. Apple. Yeah. And what is this? What is that?
Apple. Apple.
Good.
Then we also look to see how she uses it in the environment and what kind of body corroboration she might have around the words that she's learned.
What do you want?
Three.
Okay, what do you want to eat?
An apple.
Do you want some apple? I'll get you an apple. It's okay.
it will come as a big surprise to everybody that she ate the whole thing. Again, we look at a lot of behavior correspondences for the items she selects. Our research questions were 3. First of all, to what extent can we evaluate a parrot's use of the speech board? Second, what value might they place on things? Like what theme distribution emerges from the icons they select? And third, to what extent is the use of the speech board a vehicle to other kinds of enrichment in their lives? Our CHI contributions are 4, labeling and coding schema for AAC use for animals. Second, 7 months of speech board data that we analyzed through this framework. Third, we analyzed frameworks that exist for humans and how they apply to animals or don't apply, as the case may be. And fourth, we use the framework to address our 3 research questions. The data comprise video logs over the course of 7 months. Ellie averagely used the speech board 5.3 days per week and 24.1 minutes per day. She had over 5,000 selections, but about 4,700 of them were analyzed. We excluded learning practice. Her sessions were 129 days, 192 videos, and almost 40 hours of video logging. And then the caregiver is by default in unseen conditions. As mentioned before, when she's learning, we try to help her become more independent by gradually having the screen in front of us and then placing it on a speech board where she can use it independently, and the caregiver is in the room generally or behind the speech board in a way that the caregiver can't see her selections. Logging, we had 2 loggers that transcribed over 5,000 icon selections with 90% inter-rater reliability. The icon presses included menus, leaves, navigation, environmental information, time of day, location, duration of the session. It also included parent and caregiver interactions, such as who initiated it, the caregiver responses and prompts, other activities they engaged in, other AAC devices that were used, duration of activities, who ended the session. Our methods also included an automated coding and logging schema. In this way, we could place an automated theme or category for each word, and then see what themes emerged as potential value systems for her. We also conducted randomness testing on the data that emerged. Our goal was to quantify how the observed behavior deviates from random behavior, and we did this through 2 models. We created a tree with all possible menu and submenu interactions, analyzed 296 interface traversals, and excluded data from the caregiver action modifying the interface state to reduce biases. The first model was to predict the parrot's behavior using observed data, including things like luminance, location bias, number of choices available on the screen, and number of choices available total. A second model was to take the observed data and compare it with simulations. And the 3 simulations were random traversals, which were the main menu, like random selections in a main menu plus leaves or submenus, and then it ended on destinations with submenus. And then abandon was a random traversal that included the main menu, submenus, and then also abandoned at random. And we also looked at corroboration and behaviors. We had 3 different researchers with 95% inter-rater reliability look at things that could be physically and visibly corroborated, like if she asked for an apple, did she eat the apple? If she asked for a sensory experience with a book, did she engage with that? If she asked for social interaction, did she engage with that? And we looked at these in 2 ways. If it were food or beverage, she needed to take 3 bites or 3 sips or finish the whole thing, and that would count as a corroboration. And when it came to duration, she needed to engage for at least 1 minute in the activity. And then we also looked at categories for enrichment analysis. So we broke down all the icons that she has into categories. And these are the results. And we remember that what we're looking at today is a framework. We're not really analyzing whether she has intention or whether this is communication. We just look at her expressions within the framework that was developed. So comparing average session lengths, we notice that the length of time the parrot spends pressing icons doesn't match what we would expect if the bird was just pressing icons randomly. It was closer to some of the simulations, particularly abandon, but not exactly, and it was significantly different. When it came to simulated versus observed press rates, some icons were pressed more often than others, and from the data, this doesn't seem by chance. The location of the icons and how many there were in each area did matter, but there was still something unexplained that made the parrot press certain icons more. This is simulated versus observed press rate distribution when we looked at how often each icon was pressed by the bird and compared it with her simulated icon pressing. We found significant differences. The observed pressing showed more, some icons were pressed much more than others, and this didn't happen in the simulated versions. So you can see here the observed data. And then there are a lot of outliers here, which don't exist in the other simulations. When it came to the random traversal, it mimics it, but exacerbates the skew. For leaf node, it was flatter, less skewed shape than the observed, and the abandoned lacks the skew altogether. The evidence suggests that the bird is not just randomly pressing icons. The fact that some icons are pressed much more often than others, and that these patterns don't match up with what would happen if the icons were pressed by chance, imply that there may be some preferential selection of certain words over others. The bird seems to have some icons that uses significantly more than others, and the selections remain significantly different than the simulations. When it came to corroboration, again, we looked at 472 corroborable icon selections, such as food and beverages, or social interaction, or activities. Of all the 472 selections, 92% of the time, she corroborated it with either time on task or engagement. As far as enrichment value, we can see here that the percent that the bird pressed for sociocognitive, 72.5%, was much higher than the AAC distribution of 56.7%. Food and beverage was very similar, but there's also a big difference in the environmental information where the AAC distribution is 28% or 29%, but her percent selected is 12.8%. Also, as a vehicle to other aspects of enrichment, her selections resulted in 18.78 hours of other enrichment activities across 204 different items and activities. She also initiated 85% of the speech board interactions. Limitations include the fact that this is a living project. Icons are added and removed over time and based on her use. A longer study would give us a lot more information. There could be more testing around what factors influence her icon selection, and also better interface design, more animal-centered. For CHI contributions, this includes design for future enrichment for animals, such as longitudinal engagement, personalization, high levels of agency, recording the interactions within the device, flexible interfaces that are easy to use with user development that can change over time, playful interactions, and animal-centered design. And by way of a summary, we developed a framework to test the expressive and enrichment value of a tablet-based speech board for a parrot. Our aim and hope for this is that this can be useful for other animals that are using AAC devices to be able to analyze their expressiveness and also the enrichment value that it brings to them. Our first finding is that the parrot selections were significantly different than the randomness models and simulations, and she had a very high rate of corroboration with her selections that we could corroborate. The second finding is that the parrot primarily selected sociocognitive enrichment activities. And the third is that the parrot initiated most speech board interactions, and the use of the speech board resulted in a variety of activity affordances over those 7 months. Thank you so much for inviting us to speak today. If you have any questions, please feel free to reach out. And again, we hope that this provides help and service for AAC users in the future. Thanks again.